The rotor of this excavator wheel has been so severely damaged, yet it's still being repaired. In many countries, you would likely be scolded by the repair shop owner for bringing it in. However, this is Pakistan, where almost anything can be repaired. The local mechanic told me that this is a minor issue and that he can fix it for just 2,000 rupees, even offering a 6-month warranty. Given the fractured surface, glue is definitely not an option, as the damage is too severe. Welding alone wouldn't be strong enough either. However, the mechanic already had a repair plan in mind. By embedding a cylindrical shaft into the damaged hub and using a steel tube as a connecting key to join the parts together, the hub can be restored. Once the repair plan was set, the mechanic first secured the hub on the lathe and used a pin gauge to find the center to ensure the repaired hub would be perfectly aligned. Next, he proceeded to smooth out the fractured surface of the hub. The mechanic paid special attention during cutting to avoid damaging the area close to the fracture. Afterward, he used a boring tool to make fine adjustments to the hole, ensuring that the diameter matched the cylindrical shaft. Since the hub's material isn't suitable for direct welding, the repair relied mainly on threading. The mechanic machined threads on the inner walls of the hub's bore, which was crucial because tight threading would significantly increase the stability of the repaired part. With the mechanic's precise craftsmanship, the threaded hub was successfully completed. After finishing the threads, the next step was to fit the cylindrical shaft into the hub. The mechanic secured the shaft on the lathe, performing a facing operation to smooth the end surface. Since the shaft needed to accommodate a steel tube later, the center of the shaft also had to be bored to match the tube's outer diameter. The mechanic used different sized drill bits for multiple passes until the hole reached the desired size. Ensuring a smooth bore was essential to prevent issues during the assembly later. Once the bore's diameter was accurate, the mechanic measured it with calipers to confirm it matched the steel tube perfectly. After machining threads inside the bore, the mechanic moved on to processing the steel tube, which would serve as the critical component for reinforcing the repair. He turned down the outer surface of the steel tube to fit the bore of the cylindrical shaft, and then threaded the tube to match the internal threads of the shaft. Once the threading was done, the mechanic tested the fit between the cylindrical shaft and the steel tube to ensure a seamless connection. With everything fitting perfectly, he used a slotting tool to cut away the threaded portion of the steel tube, allowing for the next phase of the repair. Now it was time to handle the broken axle head. The process was similar. The mechanic used a pin gauge to confirm the center, then smoothed out the fractured surface. Since the shaft had been pre-threaded, the axle head was also machined to have matching internal threads. Under the mechanic's skillful guidance, the axle head was successfully threaded. After threading both components, the mechanic screwed them together, and the threads mached smoothly, confirming that the dimensions were spot on. However, threading alone wouldn't provide enough strength. The mechanic reinforced the connection by welding it together, although welding inside the bore presented some challenges. For an experienced mechanic, this was manageable, and he quickly completed the task. Next, the mechanic inserted the cylindrical shaft into the axle head and welded along the seam for additional reinforcement. Once the welding was complete, he used a lathe tool to smooth out the weld seam, ensuring that the joint was flush with the surrounding material. Since the hub had been machined to accommodate the threaded connection, the mechanic turned down the outer surface of the cylindrical shaft to match the bore of the hub. Once the dimensions were perfect, he threaded the shaft to fit inside the hub, providing a secure connection. The use of threading for the entire assembly was the ultimate test of the mechanic's skill. After completing the threading, the mechanic performed an initial fit check of the axle head into the hub, ensuring everything was aligned correctly. Once verified, he moved on to welding. After completing the welds, The mechanic noticed some raised areas from the welding process on the hub, which could interfere with the installation of the planetary reduction gear. To address this, he machined down the welds, ensuring the surface was smooth and met the original factory specifications. To finish the repair, the mechanic applied a layer of rust prevention paint over the surface, adding an extra layer of protection. Through this series of precise operations, the weld blended seamlessly into the hub, leaving no visible signs of repair. If you were to give the mechanic a score out of 10, how many points would you give for his impressive skill?